Yes, thanks very much, Kevin, and it's a pleasure to be here with you this morning and yeah, to hear such a buzz around the place. And look, at the work that you do every day on your farms is really important for your families, for the local rural economy, and for the country at large. And the topic that I'm going to cover today, protected urea, has generated a fair amount of conversation and debate over the year, it's fair to say. And I suppose just remembering back to the last session, you know, the point that was made there about focusing on what's most important, and you know, that most important issue of any fertilizer that we use, it needs to produce the goods in terms of growing the grass. But also as an industry, we do face challenges there to show good progress on the environmental metrics, and these include the reduction of greenhouse gas emissions. And this is why I suppose protected urea is a tool that's important for us. Over the last 20 years or so, I've run a lot of nutrient trials, including nitrogen trials. And I suppose one thing that we see is that, yeah, you can get great performance and you can get very poor performance just depending on the weather conditions. So this has an effect. So in terms of protected urea, I'm going to go through and focus on the evidence around what do we know in terms of its performance when it goes head to head in the same conditions with other fertilizers. I do want to mention as well, and Frank has mentioned it also at the beginning, look, there has been issues around spreading there this year. I'm not going to focus as much on this, but that's not to dismiss its importance. There really needs to be a focus on getting this right for 2025. So I'm going to cover the forms of nitrogen, just not to assume that I suppose everyone knows what we are talking about when we talk about protection. What is it and what does it do? On the mitigations emission side, we've done a lot of research here, research that's measured 70,000 gas samples to tell us that how the fertilizers differ in terms of their emissions. But actually what I'm going to show is a farm example of the type of impact that this can have on reducing emissions. We'll then go through the evidence in terms of herbage yield performance from published work that's been done over the last 10 years and some work from the year gone by that's not. And I also like to just round out on what's new, because we do need a pipeline of solutions for your farms for the future as well. Look, when we talk about fertilizer nitrogen, most of you will be familiar with using urea, with using calcium ammonium nitrate, which is a mix of ammonium and nitrate, and also compound fertilizers, which tend to be an ammonium and nitrate mix. But look, every year I've been at Teagasc, I've gotten more questions around liquid nitrogens. Some of you might be using those. There's various types. These tend to be a mix of urea, ammonium, and nitrate, but some products are all or almost completely all urea-based, okay? So then on to the protection. What is this and what does it do? What are we actually talking about here when we talk about protection? Well, really what we're talking about is these active ingredients, NBPT, NBPT plus NPPT, and 2-NPT. These are protecting that urea fertilizer from losing some of its nitrogen off as ammonia gas. So how many of you this year have been doing the calculation on how much fertilizer did I buy versus what my allowance is? Anyone done that sum this year? Yeah, a few hands going up. I'm sure lots of hands. Lots of you have been engaging in this. So any N that we're losing, it's essentially eating into your allowance, okay? So that's what these can do here. They keep the N in the system so that it grows the grass and I suppose can keep the same amount of N in there as calcium ammonium nitrate, which loses very little ammonia. So these active ingredients, NBPT, it's off patent technology, so there are many suppliers, okay? So that's good. Actually, at the moment, most of the blenders are using this NBPT plus NPPT protection. This is a patented product, Limerick, so you might see that on some of the hoods. Also, there's 2-NPT, which one supplier has been bringing in, and I'm also doing work with this. So we tend to think about these as, in the Irish context at least, as protection for solid fertilizers. But in fact, particularly for NBPT, which has been around for some decades, a great deal of research has been done on it internationally, and formulations of these protections are also available for liquid fertilizers, okay? So you can get protection for the urea in liquid fertilizers using these also. So what does the protection actually do? It protects urea from losing nitrogen as ammonia gas, okay? So that's N being lost. It's the same N that you're losing when you're spreading slurry, for example. And the more N that you're losing on a farm as ammonia, the less of it that's there to grow grass. So essentially that ammonia loss, it's an environmental concern, but it's also eaten into your N allowance that you need to grow grass. So making a switch from to protected urea, I'm just going to show a farm example just to highlight, I suppose, the impact that this can have on a farm for a measure that essentially doesn't have a cost or may even have a cost saving. And those type of measures are actually very, very rare. So on this farm example, this is taken from the AgNav tool, which you may be coming across and learning about in the coming years, or maybe some of you are already interacting with it. This farm example is a 50-hectare farm. It has 67 cows. It also has less than 1-year-olds and less than 2-year-olds, coming to a stocking rate on the farm of 1.9 or just under 2 livestock units per hectare. The farm N rate is 208 kilograms per hectare, and 74% of the nitrogen is in the straight nitrogen form, okay? And the rest is coming in compounds, so it's really also important, of course, when we talk about any type of straight N form that we take care of our P and K. So this farmer switched from a nitrate-based fertilizer to protected urea. So what did this deliver in terms of reduced emissions? So 33.5 tons of CO2 equivalent reduction in emissions. And to turn that into cows' emissions offset, that's approximately 7 cows' emissions that were offset. So essentially now this farmer has the emissions of 60 cows, but still has the 67 cows. So I suppose that's the power of this particular measure to deliver that reduction, without having to impact on the cow number. But look, I suppose back to that most important point of, does it grow the grass? We're going to just run through the evidence here from trials that we've done. So back in 2013 and 14, we initially did work at 3 sites comparing urea, CAN, and NBPT urea. These were plot trials, which allowed us to look at a lot of rates and also other treatments, including nitrification inhibitors. And when we bring all this data together, so this is based on hundreds of comparisons when you add up all the sites by application times, by the years, by the replications of them. We didn't detect a significant difference between the fertilizers, but it was close to detecting a difference. And if you look on this graph, the line that's tracking along on the bottom, that's the urea. That's the dark triangle. So there was a tendency for urea to have a little bit lower yield, but the NBPT urea, which hung on to the nitrogen, yielded the same as the CAN in that trial. So I suppose that gave us, showed the potential to have the same level of yield, and we were seeing lower emissions coming from the NBPT urea. Come in 2017, this work is also published, where we compared CAN versus NBPT urea versus NBPT plus NPPT urea. So how did they do in this trial? The 0N grew 4.5 ton. Adding urea took us just over 10 tons. So for CAN in this trial, there was an advantage, 833 kilograms extra yield for the CAN. So here we have a setting where CAN is growing more than urea. And that's the difference of the ammonia loss here, is the primary difference here. So now the question is, will the protected products be able to keep up with the CAN, or are they going to be back down with urea? If they're not doing their protection and they're not working, they're going to be down with urea. So the NBPT urea here grew actually 1.5 tons extra, so it was ahead of the CAN, and the NBPT plus NPPT urea grew almost 1 ton extra in this particular trial. Come along to 2019 through 2021, Anya, who spoke to you earlier, working on her PhD along with her supervisor at the time, Brian McCarthy, and colleagues at Moorpark, Clonakilty, and Athenry and Ballyhaise did some really important work taking this into the grazing setting where the cow was in the system and the rotations were shorter also. So behind this work, again, are hundreds of comparisons all put onto one graph at the 150 rate. How did these fertilizers compare in the grazing setting? So on average, the 0N, the background grew 9 tons, urea 12 tons. There was an advantage with CAN, 341 kilograms extra over the urea, and was the NBPT urea matching it? It was, okay? So it was giving additional yield also, 461 extra over the urea. They also did this work at 200 kilograms per hectare. So the application of urea took the yield up to 14 tons on average. CAN gave an advantage of 441 kilograms per hectare, and the NBPT urea 450. So again, the NBPT urea, or the protected urea, was keeping up with the CAN. So at this point, we could see that in the grazing setting also it was performing. And of all the fertilizer products that you could go out there and buy on the Irish market, there's few, if any, that have as much research done on them in Irish conditions as have the protected urea products. But look at, we've just come off of 2024. It's been a difficult spring and a dry summer, and there was a lot of questions, I suppose, as to, is it performing in these current conditions? So at Johnstone Castle, I have a head-to-head trial where we compare urea with CAN and also with the various protected ureas. So that's what you're looking at here on this graph. So each of these sets of bars represents a cut during the year in response to a fertilizer application. The first bar in each of those sets is the 0N control, and the next one is CAN, which is the orange one here, so you might look at that as your reference. And what we see here is we don't see any significant difference in the yield performance of the fertilizers when they go head-to-head, applied at the same time, cut at the same time, across the season. Now you might note that the first harvest here in this trial on the 22nd of April, that was much later than we would usually harvest these plots, just because the weather conditions were so poor. That site was saturated for a lot of the spring, so the site wasn't immune to the problems that you heard about in Ballyhaise, and that many of you, I suppose, have tried to manage through grazing in the spring. Then in May, it was getting wet, it was getting dry. We come into June, the questions were starting to come in June. This site went into soil moisture deficit, levels that were starting to impact growth in June, also in July, also in August, and we see very similar performance between the fertilizers across all these time periods. When we sum up what happened over the course of the entire year, we see that the 0N control here grew about 2.5 tons, so this site's under cutting. It doesn't have the grazing return levels that you're going to have on a grazing platform to grow those higher levels of 0N yield. But in a sense, that means there's nowhere for the fertilizer to hide. The fertilizer has to do the business in terms of producing the yield. So the urea here grew 8 tons, which is probably about 2 tons below where I'd expect to see it for this particular site. The CAN grew an extra 200 kilograms, NBPT urea an extra 130 kilograms, the NBPT plus NPPT urea an extra 264, and the 2-NPT urea just around 400 kilograms per hectare extra. So there was no evidence in this trial that a farmer making a switch from CAN to a protected urea product would be any worse off in terms of yield in the season gone by. And actually, there's also been work done in the grazing setting by Anya Murray and Brian McCarthy at Moore Park and Clonakilty. And that, again, that work is also showing in the past year gone by that CAN and protected urea performance were very similar. Okay, so look at, I suppose, just to round things out, I'd like to try and bring in a little bit of what's new as well. As part of this Department of Agriculture funded project, I've been looking at continuing to look at various N forms, including the potential of low nitrate containing liquid N fertilizer and nitrification inhibitors to reduce nitrous oxide emissions. So could they be other tools that could be useful in the future? And here's some data from some of this trial work. And what you see here is that comparing to the CAN emission factor, the emission factor for urea is much lower, but also this FlexN acidified liquid nitrogen and UAN having much lower nitrous oxide emissions than CAN. So those look promising in terms of potential to reduce emissions. We are also seeing in this work that the use of nitrification inhibitors with solid or liquid fertilizers, and they're, I suppose, a further set of inhibition technology, they can potentially reduce emissions from fertilizer down to levels of the background. So that's essentially, you're applying the fertilizer, but the emissions from the soil from applying that fertilizer are almost at the background level. Along with seeing some yield benefits, and also we're looking at the ammonia performance and that flex liquid nitrogen giving similarly low ammonia emissions to a protected urea. So I suppose this is a space that's we're continuing to work on and look for solutions in. But just to summarize, and I suppose some tips, look, I'd encourage you to use or to stick with the protected ureas. Each of you on your own farms can play a role in agriculture having the best possible story to tell in terms of emission reductions by the measures that you make in your own management. Frank alluded to at the beginning the impact that the work that you've done already is having on reducing emissions in the sector, and we need to continue that journey. Look, for 2025, there's no doubt that there does need to be a focus on this whole area of spreader calibration and the physical quality of the fertilizer and getting the two of those pieces matched up so that the fertilizer can spread the particular material you've purchased. There is potential in the liquid fertilizers to reduce emissions, so maybe some of you are already using those types of fertilizers. Also potential in nitrification inhibitors. And I want to, for just a minute, break away out of protected urea to point out that, look, if you're not already using it, and many of you probably are, a few rounds of sulfur in the system can do wonders for boosting up yield. It's going to depend a bit on your soil type. Some soils responding more than others, and maybe you need a few extra rounds there, but just think about sulfur in the coming year. We have seen substantial yield benefits with sulfur addition and also some nitrate leaching benefits, and also some work that we've just published on Sunday actually, showing the potential of plantain inclusion in swards to reduce nitrate leaching. So that also, I suppose, looks like a promising tool for the future. And look, with that, I'd like to acknowledge my colleagues and collaborators. There's a whole team of people that it takes to bring this work to fruition. And yeah, many, actually thousands of comparisons behind the data that I've shown. And the funding support that we receive from the Department of Agriculture, the Teagasc Scholarship Scheme, and also the European Union. And with that, thank you for your attention, and if you have any questions, I'd be happy to take them.